All right, so we've covered gases. Next up is liquids and solids, and some of you will probably be happy to hear this, but this section will be a lot less math intense than the previous ones. Anyways, let's just go ahead and review our three phases of matter. We've got gases, we've got liquids, and we've got solids. And of course, we can take different points of view from them, right? The macroscopic view, what we see, kind of with our human eye. If we think about gases, right, they're going to spread around all over the place and take the volume and the shape of a container. When you pour some water into a cup, it's going to fill up the shape of the container, but it's only going to take up as much volume, as it can. And then finally, solids, right? You can think about it like a little ice cube. It's not going to take the shape or the volume of the container. It's just going to be hanging out there by itself. And then, of course, we can think about what's happening on an intermolecular level. Right? What if we could zoom in on these and see what the molecules are doing? So in the gas ones, remember the molecules are just flying around all over the place, very far apart from one another. In a liquid, all of the molecules are in contact with one another, but they're free to roll around, right? So they can still move, but they're always in contact with one another. And then finally, we've got a solid. In a solid, everything is in a fixed position, right? So the molecules can vibrate in that fixed position, but they cannot move from where they are. So we'll say molecules vibrate about a fixed position. And right, thinking about these models, we can observe different properties of gases, liquids, and solids. Gases generally have low densities. Right, there's a whole bunch of empty space in a gas. That's not true for a liquid or a solid. So these two generally have high densities, at least relative to the gases. This one, of course, has a variable volume. Right, it's going to take up the volume of the container because these gas molecules are free to fly wherever they want to. While these ones on the right, the solid and the liquid, have fixed volumes. Right, they will not spread around all over the place because they are connected to one another. And of course, the gas has a variable shape. It'll take the shape of the container, and then so too does a liquid because it can roll around the place. So variable shape here as well. And then the solid will not, right? These molecules are locked into place and they cannot move from where they are. And so we can see that the major difference between a gas and then a solid and a liquid is the fact that in the gas, the molecules are far apart from one another, while in the solid and the liquid, they are touching one another, right? So, why do we have these properties? When we're talking about a gas, these molecules are flying all around the place, and the molecules don't interact with one another for the most part. They sometimes hit each other, but overall, they're not stuck to one another. Whereas in a solid and a liquid, if we have two molecules, they are attached to one another, right? They cannot leave one another. And so what that tells us is that something is keeping them together. And that something is called an intermolecular force, right? So there's some kind of force that is keeping them together. We abbreviate that as IMFs, intermolecular forces. And just, in general for science and, just, I guess, English, inter means between separate things. So in this case, molecules. So between separate molecules. Like interpersonal relationship will be between, multiple people. And then intra means within a molecule or within something. So what we're talking about here is between separate molecules. And so this is the intermolecular forces, right? When you're talking about intramolecular, you're talking about within a molecule, then you're talking about covalent bonds or other types of bonds. And so that's what we're going to take a look at this chapter. We're going to investigate these intermolecular forces. What is it about solids and liquids that keeps these particles together?